Bismillahirrahmanirrahim. Assalamu alaikum students. Today it is important lecture about the numerical problem chapter number 16, alternating current. The first problem in alternating current is represented by the equation I is equal to 20 sine 100 pi t. Compute its frequency, maximum current, RMS value of the current. We require three things. First, frequency. Second, maximum current. Third, RMS value of the current. Solution. The standard equation for alternating current is I is equal to I naught sine 2 pi ft. This is equation number 1. The given equation in the question, that is I is equal to 20 sine 100 pi t. This is second equation. A, frequency. Comparing equation number 1 and 2. So we take just value 2 pi f is equal to 100 pi. All other terms in equation number 1 and 2 are cancelled. So 2 pi goes to either side and f is equal to 100 pi over 2 pi. Pi cancel. 100 divided by 2, we get the answer. F is equal to 50 Hz. B, maximum current. If we comparing equation 1 and 2, so in first equation, I know that is a maximum value. So if we compare equation number 2, I naught has a value that is 20. So I naught is equal to 20 ampere. C, RMS value of the current, as IRMS, that is I naught over under root 2. So 1 over under root 2 value is 0.707 and I naught as it is. In B, we find I naught. So you put the value in here, I naught, that is 20 ampere. So IRMS is equal to 0.707 multiplied by 20 ampere. We get the answer. IRMS is equal to 14 ampere. In second numerical statement, a sinusoidal AC has a maximum value of 15 ampere. What are its RMS value if the time is recorded from the instant the current is 0, it's becoming positive? What is the instantaneous value of the current after 1 over 300 seconds given the frequency is 50 Hz? So we want to find two things. First one, that is maximum value of RMS, and second, we want to find the instantaneous value of the current. Solution. Given data, I naught is equal to 50 ampere. That's given in question. Time 1 hour 300 seconds. That is given in question. Frequency, that is 50 Hz. That's also given in the question. We want to find IRMS and I. So IRMS value, we know the formula. IRMS is equal to I naught over under root 2. 1 over under root 2 value 0.707 and I naught as it is. In question, I naught is given, so we put the value of I naught. IRMS is equal to 0.707 multiplied by 15 ampere. After the multiplying, we get the answer. IRMS is equal to 10.6 ampere. Now we want to find I, the instantaneous value of the current. The general equation, I is equal to I naught sine omega t. Omega is the angular frequency. We put the value in here. So I naught sine 2 pi ft, because omega is equal to 2 pi f. So I is equal to 15 ampere because I naught value is given in the question. sine 2 pi f, that is frequency, that is also given in the question, and time is also given in the question. So after the multiplying and simplify the value, we get the I value, that is 13.0 ampere. Number 3, find the value of the current and inductive reactance when alternating current voltage of 220 volts at frequency 50 Hz is passed through an inductor of 10 Hz. We want to find the current and inductive reactance. So solution, voltage V 220, that is given the question, frequency f, that is 50 Hz, that's given the question, inductor L, that is 10 Hz, that is also given the question. We want to find current I and inductive reactance XL. So inductive reactance formula, that is XL is equal to omega L. So omega, that is angular frequency, that's value is equal to 2 pi f, we put in here. So XL is equal to 2 pi FL. We put the all value in here. 2 pi, that has 3.14, multiplied by frequency, that is 50 Hz, and inductor, that has 10 Hz. After the multiplying, we get the value of inductive reactance XL is equal to 3140 ohm. So next, that is current. The current I, that is equal to V over XL. So V, that is given in the question, we put in here, and XL we find in above section, put in here. After the solving, we get the answer I is equal to 0.07 ampere. Number 4 problem. A circuit has an inductance of 1 over pi Hz and a reactance of 2000 ohms. A 50 Hz AC is supplied to it. Calculate the reactance and impedance offered by the circuit. So we want to find in this question, that is XL mean reactance and impedance. Solution, the given data, L is equal to 1 over pi Hz H, that is given the question. R resistance, that is 2000 ohm, that is also given the question. Frequency F, that is 50 Hz, given in the question. To find XL, that is inductance, or we say the reactance, and impedance Z. So first we want to find reactance. Reactance formula XL is equal to omega L. Omega is equal to 2 pi F L. So we put the value in here. 2 multiply 3.14 multiply frequency, that is 50 Hz, multiply by inductor, that is 1 over 3.14 Hz. After the multiplying, we get the answer, that is 100 ohm. Next we find impedance. The formula of the impedance, Z is equal to under root R square plus XL square. R value, that is given the question, put in here. XL we find in above section, that is 100. We put the value in here, and after the solving we get the answer. Z is equal to 2002.5 ohm. Question number 5. An inductor of pure inductance 3 by pi H is connected in a series with a resistance of 40 ohm. Find first the peak value of the current, second the RMS value, and third the phase difference between the current and applied voltage V is equal to 350 sine 100 pi t. Given data, inductance L is equal to 3 by pi h, resistance R is equal to 40 ohm, and equation of instantaneous voltage V is equal to 350 sine 100 pi t. This is equation number 1. We require three things. First, the peak value of the current. Second, the RMS value. And third, the phase difference phi. So calculation. General equation of instantaneous voltage V is equal to V naught sine 2 pi ft. This is equation number 2. For these three requirements, we first find the peak voltage, second we find frequency, then we find inductive reactance and impedance, because these all values are used in these three required formulas. So comparing equation number 1 and 2, we have V naught is equal to 350 voltage. If we compare second equation with 1, in second equation V naught, that's compared to 1, that is 350 voltage. For the frequency, we compare equation 1 and 2, 2 pi ft is equal to 100 pi t. All other values are cancelled, and frequency we get 50 Hz. Inductive reactance XL, that is equal to omega L. Omega is the angular frequency. If we put the value in here, we get 2 pi FL, and we're putting the value of all in here, so we get the answer, that is 300 ohm. Now impedance, because that is required in a peak value, so impedance is equal to under root R square plus XL square. We put the value in here, and solving by using calculator, we get the answer 302.6 ohm. Now first peak value of the current, that is V naught over Z. V naught value, that is 350, and Z, that has 302.6. After dividing, we get answer 1.16 ampere. Now second IRMS, that has formula I naught over under root 2. I naught value in first, that is 1.16 ampere, dividing by under root 2, we get the answer 0.81 ampere. Now last third, phase angle, that is tan inverse XL over R. So XL, that has a value 300, and R, that has a value of 40. That's given in the question. If we solve by using calculator, we get the answer 82.4 degree. Number 6 question. A 10 mH, 20 ohm coil is connected across 240 volts and 180 over pi Hz source. How much power does it dissipate? So given data, inductance L is equal to 10 mH. That's we converted, so we write here is equal to 0.01 Hz. H, resistance R is equal to 20 ohm. Peak value of the voltage V naught, that is given in the question, that is 240 volts. And frequency, that is also given in the question, 180 over pi Hz. We require power dissipated. So power dissipation formula, that is equal to V naught I naught cos phi. If you see in the last statement that is mentioned, power dissipation P is equal to V naught I naught cos phi. V naught, that is given the question, But I naught, that is not given the question. So first we required I naught, then we required phase difference, that is phi. So for this purpose we find the inductive reactance, impedance, and the peak value of the current. Then we find the phase, and then last one we find the power dissipation. So inductive reactance XL is equal to omega L. Omega is angular frequency. We put the value in here. After the putting the value, we get the answer 3.6 ohm. Impedance Z is equal to under root R square plus XL square. We also know the values. R, that is 20 ohm, and XL, that has a value 3.6. After the putting value and solving this one, we get the answer 20.32 ohm. Peak value of the current, that has a formula V naught over Z. If we put the value in here, V naught, that is 240 volts, that's given the question, and Z, that is 20.32. After dividing both values, we get the answer 11.81 ampere. Phase difference phi, that is equal to tan inverse XL over R. XL, that has a value 3.6, and R, that has a value given the question, that is 20 ohm. After using calculator and solving these values, we get the angle, that is 10.20 degree. Now we find easily power dissipation. Power dissipation formula P is equal to V naught I naught cos phi. Put the value in here. V naught, that has given the question, put in here 240. I naught, that has a value 11.81, and cos phi, that has 10.20. After the solving these values in calculator, we get the answer 2789.6 ohm. Number 7. Find the value of current flowing through a capacitance 0.5 microfarad when connected to a source of 150 volt at 50 Hz frequency. We require the value of current. Solution: capacitance C is equal to 0.5 multiplied 10 to the power negative 6 farad. Voltage V is equal to 150 volt. Frequency F is equal to 50 Hz. These are values given in the question. We required I. First, we solve capacitive reactance because that is a requirement of value to find the current. Xc is equal to 1 over omega C. Omega has a value 2 pi f. Put in this formula 1 over 2 pi f c, and putting the values, so we get the answer Xc is equal to 6369.4 ohm. Now current I is equal to V over Xc. V, that has value 150 volt, that's given in the question, dividing by Xc, that has a value 6369.4. After dividing both, we get the answer current I is equal to 0.024 ampere. Number 8. An alternating source of EMF 12 volt and frequency 50 Hz is applied to a capacitor of capacitance 3 microfarad is series with a resistor of resistance 1 ohm. Calculate the phase angle. For the phase angle, we first required capacitive reactance. Solution: V is equal to 12 volt, that's given the question. Frequency F is equal to 50 Hz. Capacitive C is equal to 3 multiplied 10 to the power negative 6 farad, that's also given the question. and a resistance R is equal to 1 ohm. We require phase angle. First we solve. Capacitive reactance Xc is equal to 1 over omega c. So that is equal to 1 over 2 pi fc. Put the value from above. 2 multiply 3.14 multiply 50 multiply 3 10 to the power negative 6. After solving these values by using calculator, we get the answer Xc is equal to 1062.00 ohm. Now the phase angle theta is equal to tan inverse Xc over R. Xc that has a value 1062.00 ohm dividing by 1 ohm, we get the answer theta is equal to 89.9 degree. Question number 9. What is resonating frequency of a circuit which include a coil of inductance 2.5 H and capacitance 40 microfarad? Given data, L that is equal to 2.5 H, capacitance C is equal to 40 multiplied 10 to the power negative 6 farad. These two values we put in the formula. The formula of resonating frequency F is equal to 1 over 2 pi under root LC. Put the value in here. 1 over 2 multiply 3.14 multiply under root 2.5 multiply 40 10 to the power negative 6. After solving by using calculator, we get the frequency F is equal to 15.9 Hertz. Last numerical, number 10. An inductor of inductance 150 μH is connected in a parallel with a variable capacitor whose capacitance can be changed from 500 picofarad to 20 picofarad. Calculate the maximum and minimum frequency for which the circuit can be tuned. Solution: R is equal to 150 μH. We can write this value 150 multiplied 10 to the power negative 6 H. Capacitance C1 that is equal to 500 picofarad, that is equal to 500 multiplied 10 to the power negative 12 farad. Capacitance C2 is equal to 20 picofarad, that is written as 20 multiplied 10 to the power negative 12 farad. For minimum and maximum frequency, we use a resonating frequency formula. Resonating frequency F is equal to 1 over 2 pi under root LC. For the minimum frequency, we use capacitance C1, and for the maximum frequency, we use the capacitance C2. So minimum frequency F is equal to 1 over 2 pi under root LC. We put the value in here. 1 over 2 multiply 3.14 multiply under root 150 multiply 10 to the power 6 multiply 500 multiply 10 to the power negative 12. By using calculator, F minimum is equal to 0.58 multiplied 10 to the power 6 Hertz. R we can write 0.58 megahertz. For maximum frequency, F maximum is equal to 1 over 2 pi under root LC2. We put the value in here. 1 over 2 multiply 3.14 multiply under root 150 multiply 10 to the power 6 multiply 20 multiply 10 to the power negative 12. By using calculator, we get the answer F maximum is equal to 2.91 multiplied 10 to the power 6 Hertz, or we can write 2.91 megahertz. Therefore, F maximum is equal to 2.91 megahertz and F minimum is equal to 0.58 megahertz. These two values in which we tune the circuit. I hope that will be clear. Thanks for watching. Please like, subscribe and press the bell icon.